The clock is ticking, and it could spell disaster. Doctors say the warning signs for the next pandemic are piling up fast. Deadly viruses are leaping from animals to humans, while modern travel spreads them across the globe in hours. Yet governments remain dangerously unprepared. Each warning adds up to one grim conclusion: the world is teetering on the edge of another crisis. On today's episode of the Infographic Show, we're uncovering when experts believe the next pandemic will hit. Experts warn that most new human diseases come from animals, and this is one of the most powerful engines of pandemics. Scientists estimate that over 60% of existing and 75% of emerging infectious diseases in people are zoonotic. They start in animals before leaping to humans, and that number is climbing fast as deforestation, urban sprawl, and the wildlife trade push wild species, livestock, and humans into closer contact than ever before. But how does a virus actually make the jump? First, the original host, what virologists call a reservoir species, must be close at the exact moment it's shedding enough virus to create real exposure. Then the virus needs the right molecular tools to invade our cells. Specifically, it has to wield a protein that can trick human cells into letting it in, just like flashing a fake ID at a club. Once inside, it has to replicate quickly, spreading from cell to cell, and stay one step ahead of the immune system. When a pathogen infects a victim, it replicates millions of times. This can lead to a collection of mutations that could give it the ability to survive in new hosts. Still, most attempts to cross the species barrier go nowhere. Even if a pathogen can infect a few cells, it often fizzles out or causes a tiny local flare-up. Eventually, it dies out because it lacks the firepower to pass on to a new host. But every so often, one strain gets everything right, like SARS-CoV-2 did in 2019. Virologists stress that spillover into a new species isn't caused by just one rogue pathogen. Instead, a virus exists as part of a swarm within an animal or a plant. And within that swarm, some variants might be unusually good at latching onto a host's receptors on the outside of a cell. This is one of, if not the most important steps in infecting a new species. Experts agree that a virus's ability to exploit a host receptor to slip inside of a cell is one of the best indicators of how well it can infect that species. Take coronaviruses as an example. Their spike proteins target a receptor cell called ACE2, a receptor on host cells that lets the virus slip inside. Research has shown that several bat coronaviruses already have spikes capable of binding to human ACE2. Interestingly, bats have evolved so the same receptors now block the virus. This in turn may have pressured the virus to tweak its spike proteins over time. Sometimes those tweaks accidentally equip the virus to infect a completely new species, such as humans. Other pathogens play a similar high-stakes game. Avian influenza can cross into mammals after picking up just the right mutations. In fact, livestock acts as mixing bowls, blending genetic material from different viruses into entirely new threats their human handlers eventually come into contact with. And with around 100,000 commercial flights every day, even one bad roll of the dice doesn't stay local for long. History proves how catastrophic those jumps can be. From the Antonine Plague, which killed an estimated 5 to 10 million people in the ancient Roman Empire, to HIV or COVID-19, the list of pandemics from animal pathogens is long. In the 21st century, outbreaks are arriving faster and covering more of the globe despite medical advances. And that's because globalization, dense urban environments, and even climate change keep stacking the odds against us. Climate shifts move disease-carrying mosquitoes into new territories, while booming megacities create dense, sometimes unhygienic hubs where new infections can spread like wildfire. Meanwhile, in many regions, a shortage of health workers and fragile healthcare systems leave communities vulnerable. These are often the same places where people and animals are living side by side, setting the stage for the next spillover. All it takes is one virus in the right place at the right time, carrying the right mutations to cause the next pandemic. But when exactly will this happen? When experts warn about pandemics, they typically talk about seasons. That's when odds will tilt in a pathogen's favor. Respiratory diseases don't just erupt at random, they have a rhythm, one that syncs with the weather, human behavior, and even the way your body defends itself. Looking back at history, major illnesses like the flu, RSV, and the common cold increased dramatically during the cool, dry months. In the Northern Hemisphere, winter is the prime danger window. 6 months later, the Southern Hemisphere mirrors the same peril as its own winter sets in. That's when millions retreat indoors shutting windows and crowding into offices, classrooms, and homes, the kind of poorly ventilated spaces where viruses thrive. At that same time, the low humidity of winter air helps respiratory droplets linger, turning every cough or sneeze into a floating minefield. In 2018, researchers from Harvard Medical School and Northeastern University uncovered a little-known immune defense right inside of your nose. The study revealed that cells lining your nasal passages release billions of tiny virus-killing particles when they sense an invader. This is your first line of defense against pathogens that enter through the air. Unfortunately, they also found that this response is temperature-sensitive. As the air cools, your nasal defenses slow down, leaving viruses an easier path to infect you. That means that winter doesn't just hurt us indoors, it also weakens our immunity right when viruses are most likely to strike. Dry indoor air lets virus-laden droplets and aerosols linger for hours. Heating systems keep rooms warm but strip out the moisture, allowing microscopic particles to hang in the air and travel farther. Combine that with holiday travel surges and global commuting patterns, and a local outbreak can become a worldwide emergency almost overnight. Viruses also tend to be more stable in cold, dry air. Studies on influenza and coronaviruses show that their outer shells are more durable at lower temperatures, giving them a protective armor that lets them hang around longer on surfaces and in the air. That means a sneeze on a subway pole in January might pose a threat for much longer than that same sneeze in July. Even the sun plays a role. During the shorter days of winter, UV radiation is weaker, robbing us of one of nature's best virus killers. Meanwhile, humans get less sunlight, which has been shown to lower vitamin D levels and slightly dampen the immune system. The result is a perfect seasonal storm of our defenses dipping while virus stability increases. This is exactly why authorities talk in terms of windows of increased pathogen activity. They're watching for a time when biology, behavior, and environment align to give a virus every advantage. When the first sustained clusters appear across borders in the heart of a hemisphere's winter, experts know the stakes have increased dramatically. So now we know what time of year scientists are focusing on. Let's look at the indicators that they'll use to help pinpoint when it will hit. When a mysterious outbreak starts bubbling up somewhere in the world, epidemiologists don't just sit back and wait for the headlines. They watch a network of tripwires designed to catch danger before it explodes. The World Health Organization tracks more than 30 priority pathogens capable of sparking the next pandemic. That list stretches from influenza A viruses to dengue virus and monkeypox. They're also keeping an eye on entire coronavirus subgroups, and even 2 rodent-borne viruses have made the cut. So what exactly are scientists looking for? It starts with the first flicker of unexplained illness, a local hospital flagging clusters of severe pneumonia that don't match any known pathogen. That alone doesn't mean a pandemic is coming, but it's enough to raise an eyebrow. If the number of patients needing ventilators doubles week over week and ICU occupancy skyrockets, alarms go off. Organizations like the CDC and WHO step in to try to identify if a new pandemic is emerging. Next, labs track rising positive tests across multiple regions. If a new virus sees its case count double in less than a week, that is a glaring warning that containment may soon fail. At that same time, geneticists sequence samples to see whether it's a fresh lineage of a known pathogen, one that might have mutated to dodge vaccines or prior immunity. And that is exactly how the Omicron variant of COVID-19 blindsided the world in 2021, cutting through defenses built against earlier strains. If a fresh virus evolves similar tricks, the clock to develop countermeasures starts immediately. Pharmacologists and clinicians then rush to test antivirals and vaccines. If early data shows that these tools underperform, the sense of urgency spikes. During the early months of COVID-19, early treatments offered only modest benefit and no vaccine existed, a nightmare scenario scientists never want to repeat. Epidemiologists rank threats by lethality and transmissibility. Nipah virus, for example, kills up to 75% of those it infects, but it doesn't spread efficiently between people, yet. Rhinoviruses, or the common cold, on the other hand, have a high infection rate but very low mortality rates. Avian influenza, or H5N1, mutates rapidly and already circulates in birds, pigs, and cattle, conditions ripe for human-adapted strains to emerge. Meanwhile, variola, or the virus behind smallpox, was almost eradicated in 1980, yet experts still rank it a pandemic threat since routine vaccination ended decades ago, leaving most people vulnerable if it were ever released, accidentally or on purpose. Epidemiologists warn that a new threat could surface anywhere from a livestock market in East Africa, a wildlife farm in Southeast Asia, or even a research lab accident. That's why the surveillance net of the WHO and other health organizations spans continents. Every blip, a rash of fevers in a rural clinic, an uptick in ICU admissions, or a genetic mutation spotted in a far-off lab needs to go into a global early warning system. But timing is everything. If authorities catch a virus while its reproduction number is still low, they might snuff it out. Wait until it's roaring through a city's population, and the world could be on a runaway train to the next pandemic. And the terrifying truth is the world is nowhere near ready to deal with the next pandemic. So when the next one hits, it will almost certainly be too late to stop the wave of pain and suffering that follows. What will make the next pandemic worse isn't just the virus itself, it's the gaps that we've left after the last one. COVID-19 was a brutal stress test, showing us exactly where our systems break, and many of those weak points remain. For starters, chronic underfunding still cripples basic outbreak defenses. Even after the biggest health crisis in a century, large swaths of the world can't meet key WHO benchmarks. These include surveillance, lab capacity, and emergency staffing. This will result in a dangerous lag between the first warning signs and a full-scale response. By the time a novel pathogen crosses borders and hospital ICUs surge past 85% capacity, it may already be too late to contain it. Stockpiles of medical equipment, medicine, and vaccines are another problem. During COVID-19, personal protective equipment ran dry in weeks. Ventilators and antiviral drugs became bargaining chips between nations. If the next threat spreads as fast as SARS-CoV-2 but hits supply chains harder, even wealthy countries could see shelves stripped bare and hospitals forced to ration care within days of sustained transmission. Then there is a silent killer that lurks within every healthcare facility: antibiotic resistance. Secondary infections like bacterial pneumonia turned deadly during past flu waves, and antibiotic resistance makes that risk exponentially worse. The WHO estimates that resistant infections killed 1.27 million people in 2019 and contributed to nearly 5 million deaths more. Layer that onto a pandemic, and ordinary complications such as strep infection or post-viral pneumonia could push mortality far higher. Even a modest 1% case fatality rate becomes catastrophic when the denominator is billions of people. But the world isn't standing still. After the first mysterious reports out of Wuhan on December 31, 2019, the WHO activated emergency systems. They issued guidance and declared a public health emergency of international concern weeks before the pandemic label was applied on March 11th. That speed saved lives. Since then, new shields have been built. The WHO Hub for Pandemic and Epidemic Intelligence in Berlin, the Pandemic Fund run with the World Bank to safely share biological samples, and vaccine manufacturing capacities that have also expanded as well. Yet, progress is slow and not always evenly distributed. Many countries still can't access basic healthcare necessities or pay healthcare workers reliably. Supply chains remain fragile, and equitable access to vaccines and antivirals is far from guaranteed. During COVID-19, entire regions waited for months for doses, while richer countries stockpiled. Without a binding pandemic agreement, the next crisis could devolve into another scramble of nations hoarding medicine and treatments while others suffer. Then there's a more existential crisis that hinders progress: misinformation. During COVID-19, false claims about masks, vaccines, and treatments undermined trust and slowed containment. A future outbreak could spread not just through airways, but through social feeds, eroding confidence in life-saving measures before they even launch. When people don't trust the experts trying to save their lives, they also put the people around them at risk. Guidance given by experienced epidemiologists and doctors should always be placed ahead of an influencer on TikTok or a politician with no medical background. The truth is sobering. We now have the knowledge and the technology to prevent or slow another pandemic, but the window to act is shrinking. If chronic underfunding, fragile supply chains, and misinformation go unaddressed, even viruses less deadly than COVID-19 could kill millions, not because it can't be stopped, but because we failed to be ready. So when does the next pandemic actually start? Not when the first patient gets sick, not even when a lab posts a genome online. The clock begins ticking the moment a credible health authority confirms sustained transmission in 2 or more countries and tells hospitals to activate surge protocols. That day, for all practical purposes, is the first Monday after these benchmarks are hit. But why a Monday? Well, that's when travel advisories go out, insurers reassess policies, schools debate closures, and governments advise people to stay home from work. In other words, Monday is when a public health warning hardens into global action, and history suggests that declaration often arrives in the heart of winter, while the virus has already enjoyed a 3 to 6 week head start. Look back at COVID-19. Even though the world didn't slam the brakes until March 2020, epidemiologists were on alert as early as January, after the WHO received reports of unexplained pneumonia on December 31, 2019. By January 30th, with fewer than 100 cases outside of China and no deaths, the WHO had already declared a public health emergency of international concern. Then, on Mondays throughout March, the world slowly began to shut down. Interestingly, when large pandemics arise aren't statistical flukes. This is what helps scientists predict when the next one could arise. Studies have shown that the probability of a COVID-scale event is about 2% per year. For someone born in 2000, that's roughly a 38% chance of living through one by now. For truly extreme events, like the 1918 to 1920 Spanish flu, which killed over 30 million people, the annual probability is estimated at 0.3% to 1.9%. That means another pandemic of that scale is expected within the next 400 years, and it could arrive much sooner. And as the world becomes more connected, the probability of a pandemic-level pathogen increases. There's hope in how science rose to the challenge last time. Sequencing the SARS-CoV-2 genome took just days. Vaccines were in human trials within 66 days of the sequence release, a record that saved millions. But speed isn't guaranteed. Maintaining it depends on continued funding for infectious disease research, rapid response platforms, and global public health networks. Without steady investment, we risk losing the very muscle memory that let us respond so quickly in 2020. So if you really want to circle a date on your calendar, you would have to take a lot of factors into account, and the best you could do is decide on a date with a higher probability than the others, and you would never be 100% sure. The when of the next pandemic is a moving target shaped by biology, behavior, and preparedness. But when the announcement comes, mark the first Monday after that as day one. That's when flights reroute, markets tremble, and the world holds its breath. Until then, the most important variable is us. We need to commit to trusting the experts, increasing funding for labs and health workers, and honing our early warning systems. The microbes will keep testing us. The question is whether by that Monday we'll be ready. So what's the takeaway from all this? Pandemics don't arrive with blaring warning signs. Instead, they ramp up slowly, and by the time we recognize there's a problem, the pathogen likely already has a foothold. As mentioned before, scientists estimate there's about a 2% chance every single year that an outbreak as big as COVID-19 could emerge, and that risk is climbing. The date of the next pandemic isn't something we can predict by pointing to a day on the calendar. Instead, it's the moment the data shows us something is wrong, and then other agencies decide to take action. We can't erase the threat of disease completely, but we can choose to be ready when the clock starts ticking again. Doctors may be warning about the next pandemic, but history has already shown how deadly one can be. Watch why Spanish flu killed over 50 million people, deadliest plague in modern history, to see the outbreak that changed the world, or click on this video instead.